And welcome to Cambridge Chemistry channel with Sarwat Ahmed. Be sure to like the video and subscribe it. Really helps the channel to grow. In this video, I will discuss the topics of syllabus 5070, content to be assessed in alternative to practical. Students are expected to have the same experimental skills to be developed and learned. An understanding of the same experimental context. Candidates are expected to be familiar with and may be asked questions on the following experimental contexts. Simple quantitative experiments including the measurement of volume of gas or a solution, masses, temperature, time, lengths, rates of reaction, and salt preparation. Separation and purification techniques including filtration, crystallization, simple distillation, and fractional distillation, and chromatography. Chromatography, in chromatography, you should know that how a paper chromatography is used to separate mixture of soluble substances using a suitable solvent. Describe the use of locating agents when separating mixtures containing colorless substance. Knowledge of specific locating agent is not required. So it is not required. Locating agent is not required, but in case if you want to write down that the locating agent is ninhydrin spray. Ninhydrin spray. And this is the apparatus of the chromatogram. This is beaker, and place chromatogram paper over here. This is chromatogram paper and placed in the beaker containing solvent and placed lid on the this apparatus. So this is the solvent front. This is solvent level. And this is solvent level, and this is baseline. Baseline should be above than the solvent level, and you placed mixture, like for example this is mixture X and containing 3 dyes, and this is pure red, and this is green dye. For example, if it is parallel, it means red dye is present in the mixture, in this mixture. X is a mixture, and green is not present in this mixture of dye. This solvent, this is, you should know the labeling of the chromatogram. Baseline, and this is solvent level. Beaker, and this is lid and chromatogram paper, and the process is known as chromatography. Ninhydrin spray is a locating agent, is not required. Interpret simple chromatograms to identify unknown substance by comparison with known substances. Pure and impure substances. Number 4, state and use of equation RF. RF is equal to retardation factor, which is equal to the distance traveled by the solute divided by distance traveled by the solvent. Solute is this. For example, if you want to identify the RF of red dye. So this is solute, measure with the scale, and this is solvent level. For example, this is 3 and this is 10. So 3 is the distance traveled by the solute divided by the distance traveled by the solvent. Let's say this is 10. So the answer is 3 divided by 0.3. So 0.3 is the RF value of red dye. So next topic is the electrolysis, products and substance. You should know the products and reactions of anode and cathode of lead to bromide. So PbBr2 molten. So the anode reaction is 2Br negative to form Br2 plus 2 electrons. Similarly, cathode you have done in paper 2 as well. So this is the equation of cathode of lead to bromide. Pb liquid, this is gas, this is brown color gas, and at anode product is lead, silvery lead, and brown fumes at the anode. Similarly, concentrated and dilute solution of HCl concentrated and dilute. In dilute, anode reaction is 4OH negative to form oxygen gas plus water plus 4 electron, and cathode is at cathode 2 hydrogen plus 2 electron to form H2 gas. Similarly, in concentrated HCl, anode reaction is 2Cl negative to form Cl2 plus 2 electron. Similarly, at cathode 2H positive plus 2 electron to form hydrogen gas. So these are the reaction of HCl. And similarly, the same reaction at the same equation for H2SO4. For example, if H2SO4 is written over here, so in both cases, because sulfate is not discharged at the anode, so 4OH, similar equation like dilute oxygen plus 2 water plus 4 electron. So these are the reaction of concentrated sulfuric acid. So next is electrolysis of copper 2 sulfate. Copper 2 sulfate with carbon electrode and with copper electrode. With carbon electrode, anode reaction is 4OH negative to form oxygen gas plus 2H2O plus 4 electron. Cathode reaction is 2 hydrogen ion plus 2 electron to form hydrogen gas. And with copper electrode, anode reaction is Cu solid to form Cu2 positive plus 2 electron. Cathode reaction is Cu2 positive aqueous plus 2 electron to form copper solid. So these are the reactions of the common electrolysis reaction. So next is the electroplating. And electroplating, if you want to plate silver or chromium, let's say, chrome plating, let's say if chromium plating, anode is made up of chromium, cathode is object, and electrolyte is chromium nitrate. Anode reaction is chromium solid to form 3 plus 3 electron. Cathode reaction is chromium is going to plate on the object. So these are the reaction of electroplating. And if silver metal is used, so just made silver as an anode and object is cathode. If you want to electroplating with copper metal, so copper as anode and cathode is object. So similarly, electrolyte is the copper salt or silver salt, which metal you want to plate on the object. So these are all about the electrolysis. So next is the identification of metal ions, and the test of metal ion, cation, anions and gases are given, are provided at the back of the paper. So chemical test for water test tube reactions of dilute acids including ethanoic acid, dilute acid including ethanoic acid, reaction with metal carbonate or metal hydroxide. So test for oxidizing and reducing agent, potassium iodide is reducing agent. If you want to test potassium iodide reducing agent, add Ki2 KMnO4 or any oxidizing agent, acidified, observation, potassium iodide turns KMnO4 acidified from purple to colorless. Purple to colorless. Similarly, if you ask to test of oxidizing agent like KMnO4 is used, so instead of this KMnO4 acidified to Ki solution. So the observation is KMnO4 turns potassium iodide, KMnO4 solution turns potassium iodide from colorless to brown. So you should know about the heating and cooling curves, titration, solubility, melting point and boiling points, purity, displacement, reaction of metal and halogens. These topics are very important, and I think so you have learnt in for paper 2 as well. Temperature changes during reaction, energy changes, conditions under which iron dust or other metals corrode, that is the moist air. Procedure using simple apparatus in situations where the method may not be familiar to the candidates. So these are the apparatus list. You should know these apparatus. For example, this is measuring cylinder. You should know the names of these operators. This is crucible, used to heat things such as reaction mixtures. This is beaker, to measure approximate volumes of the liquid to hold or heat liquids. So this is evaporating dish, to heat and evaporate liquids. This is flat bottom flask, to hold liquids, is not used to heat liquids in this. Dropper, to transfer small volume of liquids. Conical flask, to hold liquids, often used to heat liquids and used in titration. And this is strong test tube holder, to hold the test tubes usually when they are hot. Round bottom flask, used to heat liquids, and this is test tube, to contain liquids or small amount of solids. This is filter funnel, used to deliver liquids usually into a small moused container. This is tongue, to hold different apparatuses when they are hot, to pick hot solid objects. So these are the different apparatuses which are used in the lab, and you should know the names of these apparatus. So experimental techniques and chemical analysis, like in your syllabus point 12.1, experimental design 1, name appropriate apparatus for the measurement of time, temperature, mass and volume, including stopwatch, thermometer. 0.5 degrees centigrade is the accuracy, balance, that is 0.1 gram till 0.1 gram can be measured. Burette, this is the kind of burette used in titration. This is graduated burette, and mark is 50 over here and 0 over here. So this is the burette, that is 0.05 centimeter cube divided by 2, which is 0.1, because we take initial and final reading. So reading can be into 2 divided by the volume which is used for to measure the percentage error. Of burette is find out. For example, 25 centimeter cube is volume, so equal to, so in this way we can find out the percentage error of the burette. Volumetric pipette, it is used to measure the fixed volume of the liquid. 0.06, the accuracy is 0.06 centimeter cube. Measuring cylinder, that is 0.5 centimeter cube. Gas syringe, that is 0.01 centimeter cube is the accuracy. This is the accuracy, please keep it in mind. And 0.05 centimeter cube into 2, this is divided by 0.1 centimeter cube up till 0.1 centimeter cube. And because burette reading is measured 2 times, initial and final, so that's why it is divided to 2 multiplied by 2 and divided by 25. So gas syringe suggests advantages and disadvantages of experimental methods and apparatus. Describe a solvent as a substance. This is the definition you should know. Solvent as a substance that dissolves a solute. So this is a solute definition, as a substance that is dissolved in a solvent. Solution as a mixture of one or more solute dissolved in a solvent. So this is solution, that's a mixture of one or more solute dissolved in a solvent. Saturated solution as a solution containing the maximum concentration of solute dissolved in the solvent at a specified temperature. Residue as a substance that remains after evaporation, distillation, filtration or any similar processes. So this is the residue which is placed like this is experiment to separate solid from the solid solution. So this is filter funnel and this is residue. Over here residue, and in this solution which is soluble, that is filtrate. Okay. Filtrate as a liquid or solution that has passed through a filter paper. Acid based titration is very important. Describe an acid based titration to include the use of burette, 0.05 centimeter cube, volumetric pipette, 0.06 centimeter cube accuracy, and suitable indicator. Describe how to identify the endpoint of a titration using an indicator. Wash the conical flask with 2 liquids. Please keep it in mind. Always wash the conical flask with the tap water and distilled water. Wash the burette with liquid which is used in the burette. For example, if you are going to take HCl in the burette, then wash burette with the HCl. Pipette is more accurate than the burette and measuring cylinder. So more accurate is the pipette, then afterward is the burette, and then measuring cylinder. Indicators, there are three types of indicators mostly used. So this is very important because it is added new addition of the in the syllabus. Thymophthalene. So thymophthalene is the colorless to blue. Colorless, its color is in acid is colorless, in water is also colorless, and it is blue in alkaline solution. In alkaline solution it is blue, in water it is a colorless, acid is also colorless. So second is the methyl orange, red to yellow. Red in acid, yellow in alkaline solution, and orange in water or neutral water or neutral solution. This is orange. So methyl orange color changes always start from conical flask to burette. For example, if conical flask contain sodium this is conical flask in the titration. If conical flask contain sodium hydroxide and you are using methyl orange, so first color we add few drops of indicator over here, the solution turns yellow. And if we place acid in the burette, then acid is taken in burette HCl, and the color change will be after the neutralization. End point is yellow to red. This is yellow to red because in flask color is yellow, and after addition of HCl it will become colorless. Color change always start from the conical flask to burette. If acid is in the conical flask and alkali is in the burette, the colorless for phenolphthalein is if acid is in conical flask, then color change is red to yellow, red to yellow. If acid is in the conical flask and alkali is in the burette, then red to yellow, or if alkali is in the conical flask, then color change is yellow to colorless, yellow to red, this is yellow to red. Now next is the phenolphthalein, and for phenolphthalein color change is in acid. For phenolphthalein in acid its color is colorless, and in alkali in water also colorless, and alkali it is pink. So the color change, if sodium hydroxide is taken in flask, then color change is pink to colorless, and if sodium hydroxide is taken in burette, then colorless to pink. For methyl orange, red to yellow, and vice versa. So this is the burette reading and how to take burette reading if calibration results are given. So this final burette reading, this is experiment 1, experiment 2, and experiment 3. This is final burette reading is 25.6, and initial burette reading 0.0, and in this case 28.2 is the final burette reading and 3.6 is the initial burette reading. Similarly, 36.3 is the final burette reading, and initial burette reading is 1, 2, 3, 4. 11.4 is the initial bureau reading, and this is equal to 25.6, and this value is equal to 38.2 minus 3.6, so it is equal to 24.6, and this value is equal to 36.3 minus 11.4, it is equal to 24.9. So best titration result is 24.6 and 24.9. Now this is a collection of gases. The downward delivery, the gases which are heavier than air are collected by downward delivery and upward displacement of air. Heavier gases like CO2, H2S, sulfur dioxide, because air mass is 30, 28 to 30, let's say 30, approximately 30. So if the mass is higher than 30, then the heavier gas like collected are like this, and if the mass is lower than like ammonia, hydrogen gas are collected like this. And if the gases which are insoluble in water can be collected by using this separator, and hydrogen is insoluble gas, hydrogen is insoluble, CH4, C2H6, C3H8, C4H10, and similarly C2H4, C3H6 and C4H8 are insoluble gases. And neutral gases. Neutral gas is carbon monoxide, nitrogen monoxide. So and insoluble gases. These gases are collected by using this separator. Upward delivery, ammonia and hydrogen gas. Downward delivery, carbon dioxide, chlorine and sulfur dioxide. This is the apparatus used to measure the rate of reaction. Experiments, this is conical flask and the reacting solid and liquid, gas syringe, density does not matter, so gas is collected over there. This is gas syringe and this is the delivery tube, and the gas which is produced during this reaction is collected in the gas syringe. So this apparatus is used in rate of reaction usually. Next is solvent to be removed: water, ethanol, methanol and hydrocarbon. These are the, if we want to remove solvent from the any solution or any substance, we can use for water silica gel, calcium chloride, solid potassium hydroxide, phosphorus P2O5, concentrated phosphorus trioxide, concentrated sulfuric acid. So water is removed from these by using these drying agents. Water is removed from any substance by using these reagents, and ethanol and methanol by using calcium chloride, and hydrocarbons by using paraffin wax. And keep it in mind that this is corrosive, and this is also corrosive liquid. Glass masks can be used. Safety precautions for poisonous gases, chlorine, nitrogen dioxide. The experiment including in which chlorine or nitrogen dioxide gases evolve can be conducted should be conducted in fume cupboard. This is the precautionary measure, the safety precaution if chlorine gas is evolved in any experiment. And it often asks you that which safety precautions are used, so experiment should be conducted in fume cupboard. Paper 4, alternative to practical tips: when plotting graph, you should be able to accurately plot to within 1/2 a small square and lines should go through the 0.0. For example, this is the graph. This is 0.0 line and pass from this, which should also be plotted if there is a data, and if there are straight line like this. So this is the straight line and this is going to intersect. So often ask you to draw graph by intersecting two lines. If some points are like this, so first draw this line and then draw this line. This is the intersect point. Okay, if it is clear that a trend shows that line is unlikely to go through this point, practice extrapolating. This is extrapolation. Extrapolate the graph. The extrapolated curve must follow the pattern of the line or curve that is already there. If it is leveling off gradually, the extrapolated curve must continue this leveling off. In the practical papers, marks are not usually given for suggesting that we can separate a solid from the solution by decanting of the solution. Filtration is method that is expected. So always use filtration to remove insoluble solids from the solid solution. Make sure that you know the difference between the test for oxygen and hydrogen. These are the frequently muddled. Hydrogen lighted supplant pops in flame with lighted supplant, and oxygen relights the glowing supplant. If you are asked to state test for hydrogen, do not just write down use the POPs test. This description is too vague. It describes the result and not the test. It is for the better to write insert a lighted supplant into the test tube. In describing color changes which you expect to see when a metal such as zinc reacts with a solution of copper sulfate, don't write that the solution goes white. This is a common error. You should state that the blue colored solution loses its color. You are given several diagrams of thermometer showing the temperature as an exothermic reaction proceeds, and then have to plot a graph from the data. Make sure that you always calculate the temperature change by taking away the initial thermometer reading from each of the other readings. Don't take the third from the fourth from the fifth, etc. Always calculate the temperature change by taking away the initial thermometer reading. Make sure that you know the solubility rules for various compounds. These are the important when writing state symbols in equation. If you know the carbonates of group 2 metals are insoluble in water, then you know to write calcium carbonate solid in an equation rather guessing. When deciding which method to use to make given salt, you need to be able to remember to use the solubility rule. For example, to make an insoluble salt from the two soluble salts, you use precipitation reaction. In order to make a soluble salt from two soluble salts, you use titration. For example, in precipitation, barium nitrate, 2 aqueous salts plus sodium sulfate to get one insoluble, and BaSO4 is insoluble, plus sodium nitrate. So this is aqueous salt. So in titration, group 1 salts are prepared by using titration and ammonium salts. Know the difference between aqueous and liquid. The state symbol aqueous refers to the substance dissolved in water. The state symbol L refers to a substance as a pure liquid. For example, bromine is a liquid, water is a liquid. Remember that when writing equations for the reaction between aqueous solution of halide and aqueous halogens, the state symbol for all aqueous. This is because the halogens are dissolved in water. This is very important. For example, if write down like this, 2Br negative to form 2Cl negative plus Br2. So this is also aqueous. This is very common equation. Please learn this distillation reaction by heart. This is also aqueous. This is another Br2 plus 2 iodide ion. These are the common questions from the examination point of view. So 2Br negative, and color change in both cases, colorless to brown, plus I2. This is aqueous, aqueous. When asked to draw a diagram, make sure that you have included all the pieces of apparatus necessary. Go over each point in the question carefully to check. It is quite common, for example, to leave out the test tubes to collect gases when asked to draw the apparatus for the electrolysis and test of the gaseous compound. Plan experiment and investigation. Identify the independent variables and dependent variables. An independent variable is the variable that is changed or controlled in a scientific experiment to test the effects on the dependent variable. So independent variable always at y-axis. This is independent, and at x-axis is the dependent variable. A dependent variable is variable being tested and measured in a scientific experiment. The dependent variable is the factor that the research measures. It changes in response to independent variables or depends upon it. Describe how and explain why variables should be controlled. A control variable maintains a consistent state throughout an experiment or research, like keeping temperature constant. So this is the control variable. Suggest an appropriate number and range of values for the independent variable. Suggest the most appropriate apparatus or technique and justify the choice made. Describe experimental procedures, identify risks and suggest safety precautions like chlorine gas. If chlorine gas is involved in any experiment, so for chlorine gas experiment should be suggest that experiment should conduct in fume cupboard. So this is safety precaution for chlorine gas and nitrogen dioxide, which are toxic gases. Describe how to record the results of an experiment. Draw a suitable table and record the results of an experiment. Describe how to process the results of an experiment to form a conclusion or to validate a prediction. So at the end of experiment, in planning and design, always write down the conclusion or result. Make present predictions of expected results. Colors of elements and compounds are very important to learn. So group 1, 2 and aluminium, zinc metals are usually silvery or silvery gray metals. Transition metals are usually dark gray solids. Other than transition metals, compounds are white solids and their solutions are colorized. Lead forms yellow lead oxide solid, whereas the compounds of lead are white. Other compounds of lead are white, but lead oxide and lead iodide are yellow. Transition metals form colored compounds and their aqueous solutions are colored. Copper is pink brown metal, and following are some of its colored compounds. Copper sulfate anhydrous white powder salt solid, copper 2 sulfate hydrated blue crystalline solid, copper sulfate aqueous solution blue, and CgCl2 solid and solution turn green. This is CgCl2 color is green, CgCO3 copper 2 carbonate is blue green, copper 2 hydroxide is blue solid, copper oxide is black, and copper 1 oxide is brick red solid. Iron is a dark grey solid and it forms following colored compounds. Iron 2 salts, FeCl2, FeSO4 solid or solution green or light green, FeOH twice, iron 2 of hydroxide precipitate, dark or dirty green precipitate. Iron 3 salts are brown or red brown, FeCl3, iron 3 sulfate yellow brown solution. The solid is brown or red brown, but if iron 3 are in aqueous solution, the color is yellow brown. Iron 3 hydroxide precipitates are red brown. Iron 3 oxide is rust brown. Iron 4 oxide is Fe3O4 is hematite. This is magnetite and this is hematite. Solid blackish brown. Nickel gray metals form greenish solution. Green, not greenish. Green solution. Light green solution of nickel ion. And certain non-metals or their compounds are colored. Sulfur S8 is a yellow solid. Phosphorus, this is the molecular formula. This is molecular formula of phosphorus is a red solid. Fluorine is yellow gas in colorless solution. Chlorine Cl2 yellow green colorless aqueous solution, white precipitate with chloride ion. Bromine red brown liquid aqueous solution, vapors creamy precipitate. Red brown in liquid or aqueous solution or in vapor form. Creamy precipitate with bromide ion. AgBr is creamy precipitate. AgCl is white precipitate. AgI जो silver iodide is yellow precipitate. But the iodine black solid brown solution, iodine liquid is in brown solution, iodine vapor gaseous form is purple vapors, and iodide ion with silver iodide is yellow precipitate. Nitrogen dioxide brown gas, hydrogen chloride gas white mystery fumes. This is the observation. Other gases such as oxygen, nitrogen, carbon dioxide, ammonia, carbon monoxide are colorless. Redox reaction test, I have earlier discussed about the redox reaction test. H2 potassium manganese to colorless, and this is very common question from the previous year, like he asked you that potassium manganate redox titration, that KMnO4 react with Fe2, and the color change is purple to yellow or green to yellow. This is iron 2 is taken in class, and the color change is colorless to yellow. Why colorless to yellow? Because purple to yellow. Purple to yellow. Why purple to yellow? Because KMnO4 oxidizes iron 2 to iron 3, and I have earlier discussed that iron 3 aqueous form makes yellow colored solution. So that's why this is oxidized to iron 3. So iron 3 is present in the solution. The color change is yellow. Acidified potassium dichromate orange to green. Test for oxidizing agent. Use aqueous potassium iodide, and the color change is colorless to brown. Test for oxidizing agent aqueous potassium iodide, colorless to brown. And similarly, organic chemistry test, unsaturated alkene, orangish, not orange, orange brown to colorless. Alkene turns bromine from orange brown to colorless. Saturated, no change. Test of water anhydrous copper 2 sulfate turns from white to blue. Anhydrous, anhydrous means without water. Purity of a substance test sharp and fixed melting point. Melting and boiling point is used to check the purity of the substance. Indicators I have discussed earlier. The litmus is red and blue in alkali, methyl orange red in acid, yellow in water, orange in water, orange in water, and yellow in alkali. Similarly, phenolphthalein colorless in acid, colorless in water, and pink in alkali. Always remember for pH determination, universal indicators, reference to color matching with pH color chart paper. pH meter, thymophthalene, acid, water, alkali, colorless to blue. So, apparatus involving which calculation titration reading is required. For example, this is the student does 3 experiments and the result is this. So, take the best titration results in the table, use the take results to calculate the average volume. So, first select the best titration results. You know these are the two nearest values, 24.1 and 24.3. So, this is the best result. So, by using so always if write down calculate, then this is calculate, write down written as a calculate the average volume of M. So always take 2 best citation and divide by 2. This is equal to average volume of M. So he asked you that solution M is 0.050 mole per dm cube sulfuric acid. Calculate the number of moles of sulfuric acid in the average volume of M used in the titration. You know that this is the mean average volume of M used in the titration. The mole is equal to concentration to volume over 1000. 0.0500 is the mole per dm cube is concentration, and this is the volume. So we get 0.00121 is the answer. The next is dilute sulfuric acid react with aqueous sodium hydroxide as shown. So we have to calculate the mole of sodium hydroxide. So first by using mole ratio 1:2, 1 mole of sulfuric acid reacts with 2 moles of. So what would be the mole of is 0.00121 react with the x mole. So now we have this is the sodium hydroxide mole. 0.00242 mole is the sodium hydroxide. Calculate the number of moles of sodium hydroxide in 500 centimeter cube of L. You know that in 25 centimeter cube has 0.00242 mole. So what would be the mole in 500 centimeter cube? By using mole ratio volume, 25 centimeter cube, 0.00242 mole in 25 centimeter cube volume. So what would be the mole in 500 centimeter cube? So in this way, 0.0484 moles are in the sodium hydroxide. So calculate the number of moles of sodium hydroxide in 25 centimeter cube. So same moles are there in 25 centimeter cube. K is also 0.0484. This is the solution. Sodium hydroxide is 25 centimeters. So already we have calculated. So we calculate the concentration of sodium hydroxide in K. We know the concentration is equal to mole over volume into 1000. So concentration is 0.0484 divided by 25 into 1000. So this is the concentration formula, mole over volume into 1000. Concentration always measured in mole per dm cube. So this is volume in centimeter cube. So divided by into 1000 to convert concentration in mole per dm cube. So this is the concentration. Between each titration, the student washes the conical flask with water. A second student repeats the experiment but uses L instead of water to wash the conical flask. State and explain whether the second student's titration volume of dilute sulfuric acid would be smaller, larger, or unchanged compared with the first. This is a very common question. In every most commonly asked by the examiner in this experiment. So he asks you that conical flask, student washes the conical flask with water. A second student repeats the experiment but uses L instead of water. L is washed with water to wash the conical flask. L instead of, L is the solution, so L instead of water to wash the conical flask. The volume is larger as more sodium hydroxide is in the flask, because if we wash the flask with the L instead of water, so there will be more volume in the sodium hydroxide in the flask, so larger volume of H2SO4 will be used by second student. So this is the question. So this is all about the tips and how to handle the question in the exam. So I have already uploaded many videos on plan and design experiments. Please watch those videos for best preparation of your exam. So hopefully you understand.